9.6 I like more than 9.5, and that 9.5 with the solving by graphing is just a pain most of the time, it seems. 9.6 you have to do some factoring, but most of the times if you're going to use this at the end of the chapter, when it's kind of like, here, figure out the zeros for these functions. If you look at one and it's easy to factor in your head, chances are you'll just do the factoring. Otherwise, you'll do one of the other ways. So typically, the factoring, don't let that intimidate you. It's going to be ones that are nicer to factor. But before we get there, I'm going to start here. If you have if you have a number times a number, and you know that equals 0, what has to be true about one or both of those numbers?
0.
One of them has to be 0. Agreed? Because the only way, say the first one is a 5, I don't think I'd write this down. If the first one's a 5, the only way to make that equal 0 is to multiply by 0. You can't multiply by 1/5, you can't multiply by -5. It has to be times 0. So when you have one like that, you know, so given that, what do you know? One or both must equal 0, or must be 0, maybe I should say. But one or both of those number things there must be 0. So in other words, when we have a problem like this, so say we have some equation, a 3x squared plus 7x minus 12 or something like that equals 0, if I could factor this side here and make it be something times something, that's going to equal 0, right? So then one of these two has to be 0. That if this is 0, I'd get a 0 of the function, I'd have an x-intercept. Or if this one's 0. So we'll go through and actually kind of do that. So I'm going to assume we had this, the last step, so we already factor it, this one to get this right here. So we know either x minus 7, I would write this, x minus 7 equals, you're breaking my heart, x minus 7 equals 0. So either this first one has to be a 0, or my second one has to be a 0. Or x plus 2 equals 0. Do you agree one of those two things in parentheses has to be 0 for the whole overall thing to equal 0? And from there, then, you just go through and solve it. So, well, what x value would give me that first one being 0? Well, x could be 7. So one of the places that this graph then would cross the x-axis would be a 7. Or my other one, I could subtract 2 from both sides. My other x-intercept, the other place it crosses the x-axis, is a -2. Because those are the two x values that will give you a y value of 0. Make sense? And so now if we want to go through and actually kind of do the whole thing beginning to end, just have a couple examples here. Well, I have this exciting little trinomial here. Trinomials we break up into a binomial times a binomial, right? Because my original equation equals 0, we know once we factor it, get the same thing as this in a different format, it'll still have to equal 0. At the beginning of both binomials, I have an exciting letter we call x. If I have a minus here and a plus here, my signs have to be minus, minus. That the only option here to get a plus something is going to be plus, plus, or minus, minus. If that's a minus, then we know it's the minus and minus. I'm hearing a 4 and 2. Do we like that?
Yeah, sure.
Because 4 times 2 gives me 8. And then the outside would be minus 2x, inside minus 4x, for a total of minus 6x. Nice. So still tracking with me? Yeah. Then we just do what we did before. So x minus 4. This first one could be 0. Or x minus 2. My second one could be 0. Go through and solve it for x. So my x value could be 4. Or plus 2. My other x-intercept, my other x value would be a 2. Yeah, isn't that way better than graphing?
Yeah.
And if you had something that, by the end of the chapter at least, is just really hard to factor, well, then you just do it a different way. Who sees this next one? How do we factor that bad boy? Go for it.
X.
If this was a trinomial, we could do the binomial times a binomial like the last one, right up there. It's a binomial, so does it fit that binomial squared? No, but the first thing we do before I should have even checked that is to pull out the greatest common factor. You agree they have an x in both of those?
Yes.
So an x in both terms. When I pull an x out of that first one, so x squared, take out an x, I'm left with x. Then I have plus 7x, take out the x. plus 7. So now we have two different parts there. We have this part and we have this part. They're multiplied by each other, so we know one of them has to be
0.
perfect. So either x equals 0, that one's kind of done for us, or x plus 7 equals 0. So a lot of you just look at it in your head and you know it's negative 7, but I'll show my work. X equals negative 7. So I have two options. X could be 0, or x could be negative 7. So those are two x-intercepts. No, once you have that, you're done. Once you have that, you're done. So next one here, a diver's height, throw the story problem at you, and I think this is where we end. How much time does it take her to reach the water? So we have, does anybody look at that and know the diver's initial height? 8. Yep, 8 feet. Nice. So she's on like an 8-foot high dive or something like that. And she's jumping upward. That's what this comes from. The plus 8 means she's jumping upward. That doesn't matter a ton, but so it's going to look something like this. Fair enough? Does this part on the left, does that matter at all? No, because that's like before she jumps. That's just kind of finishing out the parabola. So we can kind of ignore that thing. What we're really looking for is that number right there. All right. How much time does it take her to reach the water? Well, if we have that, what would be my first step in factoring this thing? I could do two binomials, or we could pull out an 8. Could I convince you, if we pull out an 8, you agree I'm going to have negative 2t squared plus t plus 1. This negative 2t squared is kind of ugly. So instead of pulling out a positive 8, could I get you to pull out a negative 8? And when we do that, so I'm going to pull out a negative 8. I'm left with 2t squared plus, minus t, wouldn't it be? So minus a t and then minus 1. And we're trying to figure out when does the height, this thing here, when does that equal 0? All right, so this negative 8, that's just, you kind of just lose that at this point. But we could factor this thing in the middle, agreed? And so I guess we could include the negative 8. But the negative 8, when you break all these up and say, well, one of these three things has to equal 0. Do you agree the negative 8 can't equal 0? No. Negative 8 can't be 0. So we need to factor these two, and then one of these two has to be the one that's 0. All right, so if I have this positive 2t squared, do you agree I need a 2t and a t? If I have a minus 1, my signs have to be plus and minus. Well, we have more minuses, so I'm going to take and put my minus right here, thinking that that'll back up to that 2t. And the only combinations that'll give us a 1 would be a 1 and a 1. So if this doesn't work when we check it, then you just have to switch your pluses around or switch your 2t around. But so I go through positive 1 times negative 1 gives me negative 1. Here I have minus 2t on the outside, plus 1t gives me a minus 1t, and a positive 2t squared. So we're good. Cool. You with me up to there? Let's go back to the last chapter. So now we know then either the 2t plus 1 has to be 0, or t minus 1 equals 0. Anybody see which one it has to be already? Which one's going to give us the positive? Plus 1, plus 1. So this one here, t equals 1, tells us that she's going to hit the water at 1 second. We could go through and do the same thing on the other side. Minus 1, 2t equals negative 1. Divide by 2, divide by 2. T equals negative 1/2. That was the other side of the parabola, what she would have had, right there before she took off. So that was the extraneous one, the one that didn't make any sense. So t equals 1. She hits the water at 1 second. So, work for you guys? Questions on any of that? So, awesome.